All right, everyone. So I'm going to continue talking about the total force exerted on the metal plate when the plate is not 100% level with respect to the height or the depth of the water surface. Okay, related to the water surface. So this part right here is more shallow than this part right here. This is deeper. So the force in here is going to be greater. The force in here is going to be a little bit less. The force in here is going to be less. And it keeps going less and less and less and less. So adding all these forces, okay, adding all the pressures in each one of these areas, you're going to get all the forces, right? Because it'll be this pressure times this area plus this pressure times this area plus the pressure in here, which increases, times this area. So the pressure keeps increasing. So the force keeps increasing because force equals pressure times the area. Okay, so here you have the sample of a vertical bar, a horizontal bar, right? This delta y, as it becomes infinitely small, is going to become dy. So it's like I was saying, if you want to know the total force exerted on this metal plate, it'll be the total force is going to be the weight density, okay? The weight density is mass divided by volume times the gravity when the volume is 1. Okay, so being the volume 1, this is going to be mass times gravity, which is the weight. That's why it's called the weight density. It'll be the number of pounds per cubic unit. Could be cubic feet, cubic foot, cubic inch, cubic centimeter, whatever. Okay, so the force is going to be the weight density, which doesn't change, okay? You have to assume that the density is not going to change. For that, you have to assume that the fluid, either a liquid or a gas, is incompressible. You cannot compress it, which is, it usually happens to a liquid. Even if you compress it, it's very little. But a gas is something else. It compresses. And the more it compresses, I mean, you can compress you can compress a gas to a certain point that it becomes a liquid. So we're not talking about gas here. Consider that this is water, okay? And it'll be times the integral, okay? And now we're gonna see that, well, it'll be L of y, okay? I know it's L of yi here, but it's because it's the L of y of one of these horizontal bars. But since we're doing the integral, okay, from C to D, from C to D, it's a small d up there. It'll be L of y times dy. Now L of y times dy is going to give an area, okay? Pretend, I don't think this is going to show up. Let me try this. Pretend that this thing here is becoming infinitely small, infinitely narrow, okay? I know that it's not narrow here. You can see that the width is like this, but pretend that this width is infinitely small. You're still going to have an area, okay? You're going to have L of y times the area, right? Times the height. The height's just going to be minus y, okay? You're considering that this point right here, I'm going to choose something black, or maybe this color here. You're considering that this point right here, this one, is 0, 0. All right? So keep that in mind. All right. A vertical gate, okay, now we're going to try to do some exercise. A vertical gate in a dam has the shape of an isosceles trapezoid, 8 feet across the top and 6 feet across the bottom. Okay. With a height of 5 feet, fine. As shown in figure 7.71a, I'm going to paste the figure for you. What is the fluid force on the gate when the top of the gate is 4 feet below the surface of the water? Okay, so the figure that they're talking about is this one. I'm not going to erase this. I'm just going to paste the figure here. This is what they're talking about. Okay, so you got to consider that this point right here is 0, 0. All right. Now let's try to apply this formula to this situation. All right, so let's see. The force is going to be equal to the weight density. Now the weight density, let me see here, because it depends on the unit, guys. It's still 62.4. It's probably pounds per cubic foot. Okay, so it's going to be 62.4, and then you do the integral, right? Since it's going to be from C to D, which is from bottom to top, then it'll be from minus 9 to the minus 4. Okay, minus 9 to the minus 4, and then you go Ly. So what is going to be the distance from, what's going to be this length right here? Okay, let me get something dark, or just make sure this length right here. How do you calculate that in terms of y? Okay, so let's see. You can use the point slope equation to get the value of this line right here. Okay, so I'm going to turn this into something like y equals, I'm going to use the point slope equation. So for this line, I'm even going to leave this line in here. For this line in here, well, I'm going to take it out so it doesn't become too cluttered. All right, this line, okay, is going to be y minus, and I'm going to use one of the points. I'm going to use the bottom point there. So it's a minus 9, which is a plus 9, equals the slope. The slope is the rise over run. Okay, so as it goes from 3 to 4 in the x-axis, it goes from minus 4 to minus 9 and minus 4 in the y-axis. So you're gonna be 5 on the rise over the run. The rise is 5 and the run is 1, so the slope is 5. Okay, and it's gonna be x minus 3, because this is in the form y minus y0 equals the slope x minus x0, and the y0 here is going to be minus 9, the x0 is going to be 3, okay, because the point is 3 minus 9. All right, so let's do this. Y is going to be equal to 5, oh man, it's going to be equal to 5x, and then you go minus 15 minus 9 minus 24, right? But here's the thing, what is the value of Ly? The value of Ly is not y, it's x. So what you want is, because we're integrating with respect to y, you don't want a function of x, you want a function of y. So we're going to isolate this x in here. X is going to be equal to y plus 24 divided by 5, okay? So that's the value of x. So according to a certain y, if I give you the depth, you're going to be able to find the x. All right? For example, if I give you this depth right here, okay, you're going to be able to find this value of x. But here's the thing. The length is twice that much, all right, because this is symmetrical. So we got to multiply this by 2. I'm just going to put a 2 here. Because you see, I'm multiplying everything by 2 and dividing everything by 5. So I'm just going to drag this over. I'm going to drag this over here. And I'm going to put 2/5 times this. 2/5 times this, okay? All right, so this is going to be the value of x, which is actually like, this is 2x. All right, and you got to put that in Ly here, all right? So the Ly is going to be 2/5. Man, I have such a hard time making a 5. I don't know why. Y plus 24, all right? And then you have the depth, which is just going to be minus y. All right. Why isn't it going to be y? Because the depth is increasing, but as the depth increases, the y decreases, right? Because the value of 0, 0 is in here. Okay. So times minus y dy. That's going to be the force. Oh, I'm sorry. I'm nuts. Okay, it's over here. Minus y dy. Okay. So let's just erase this. And now, well, the force is going to be equal to, I'm going to get this 2/5 out of here because it doesn't matter. So it'll be 124.8 divided by 5 times the integral from -9 to -4 of, let's see, it'll be minus y squared minus y squared minus 24y dy. So let me just copy this. The force is going to be equal to this, and now let's just erase that. I'm going to have to erase most of it. So it'll be from -9 to -4 minus y cubed divided by 3 minus 12y squared, because it's minus 24y squared divided by 2 minus 12y squared. Okay. And now all you gotta do is plug in these values. So guys, I'm gonna give you the straight answer, okay? So you see, well, maybe not, maybe I shouldn't do that. Well, I'm gonna set it up. So it'll be the force equals 124.8 divided by 5, okay? And then you go like times. First you put the -4, okay? So you got a minus, cubed is just gonna continue being a minus, and you got a minus here, so it's gonna be a plus. So it's going to be 64 over 3. All right. And this one here is going to be a minus because 16 times 12, but there's a minus here. Okay. So it'll be 16 times 12. I'm just going to set it up. And now you got to do the same thing using a minus for this -9. So you got a minus here, cubed is going to be a minus. With this minus plus with another minus. So it'll be 9 cubed divided by 3. Okay. Now here's the thing. 9 is 3 cubed. I mean it's 3 squared. So this is 3 to the 6. So it'll be 3 to the 5. Okay. This is going to be minus 3 to the 5th. And now you're going to put another -9, okay? So it'll be 81 with this minus. It'll become -81 with another minus plus 81 times 12. Plus 12 times 81. So if you do that, it'll be equal to 13,936 pounds. What does that mean? It means that this is the force being exerted all over here, okay? But it's not equally. Oh, that means that you have 13,936 pounds here, 13,936 pounds here. No. It means that if you add all the force over here, plus the force here, plus the force here, plus blah, 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 everything added together is going to be 13,936. But the force in here, okay, is going to be a lot less than the force over here. Because the force over here is the pressure, right? And we know that pressure equals force divided by the area. Therefore, force equals pressure times the area. So it's directly proportional to the pressure. So the pressure up here is going to be a lot less than the pressure down here. The more you go down, the more pressure you have, right? So, yeah. Let me see if I'll do another exercise here, if it's okay for this video. I think it's okay for this video because these exercises are long. I'm going to leave the next exercise for the next video.